Hello everyone, my name is Tom, and this is the report on the project 3 and 4 of the data science internship provided by Oeson. And in this project, I have performed a detailed EDA on a student dataset, and I also tried to deploy several efficient machine learning models on the training dataset. And I also plot out some of the charts so I can bring out some necessary information from the dataset. And then finally, I will state my own statement. So with some of the relevant findings. So first of all, I have import some of the necessary library. We are seeing here is that we having some of the methods that can help me with the pre-processing and perform EDA. And there are some algorithm as well. So I'm using several algorithms so we can compare them together and then make our statements on which one maybe is the best for this current situation. I also using the TensorFlow for the artificial neural network or as a one algorithm. Okay, so the first thing is that I connected the data, and we can see that the data will have 35 features, and the last one is a label that we need to predict on. So we are predicting that whether a student is gonna drop out from the uni or not. All right, and then I perform and look at the descriptive statistic. So, and then I checking the missing values. From this information of the data, you can see that the data is already very clean and it has no known values anywhere. So, so I just do this so I can show you the table that there's no missing values for the data. And as you can see from the target column, that our data, the label data, the target data, then doesn't have the numerical data type. So we have to convert this into the numerical data type. So this is what I'm doing here. So I'm converting categorical labels into numericals. So I'm using the label encoder from Scikit-Learn to easily to do this. And after we convert it, so I indicate the 0 as dropout, the 1 is enrolled, and 2 is graduated. Next, I will finding outliers. So first I draw the drop box right here. So we can see that there are several outliers from the data. There's one right here from the feature number 17 at the index 17. We have the outliers right here, and so on with the 21, and this one as well. So by looking at this box plot, I can see which features is currently have the outliers. Then I define them in here. So these are the index of the features that currently have the outliers, and then I try to eliminate the outliers by using the IQR method. And after the elimination, I have eliminated 108 outliers from the data, and it's results in 4,316 examples. So let's look at the box plot after removing the outliers. So as you can see here, the outliers right here is this has been removed. It has been removed, and similar to the other features. Okay, so next I got the features and labels separately. And then I standardize all of the data using this method from the Scikit-Learn. And then I will perform the PCA to reduce the dimensional of the data. So I'm using the singular value decomposition method to find the suitable k value, which is the number of dimensional that is optimal for this data. And I use but first I need to compute the covariance matrix. This is also a method from NumPy, so we can easily compute the covariance matrix using this method, and then perform a singular value decomposition method. After that, we will find the most effective k for this data. So it's currently in here we have 29, so we reduce 35 features into 29 as in terms of dimension. After I found the k, I fixed the most appropriate k. I performed the PCA with the corresponding k value, and then I split the data into the training dataset. So now let's move on to the modeling. So I have several models that I need to compare. The first is at the logistic regression. Then I fit the training set, and then we saw that the accuracy right here. Each of the model, I will perform the confusing matrix, and then the classification matrix reports on it as well. So we can clearly see all of the accuracy of the model. So this is the logistic regression, the decision tree, the SVC, the Gaussian noise bias, and the k nearest neighbor. But for this k nearest neighbor, I just choose the optimal. I just found the optimal k neighbors is 15, so I use this one as is showing the highest accuracy from the dataset. And then the random forest as well. I also compare to the gradient boosting classifier. For this algorithm, I also found the learning rate that is optimal for the dataset is 0.1, and the max depth is 3. And finally, I'm using the artificial neural network provided by the TensorFlow. So with this artificial neural network, we having 2 hidden layers, and each of the layers have a 1,000 neural, and we using the the function of activation is ReLU, and for the final output layer, I'm using the sigmoid activation function. Sorry. So after it's run, after running the artificial neural network, I'm comparing the ROC curves of all the algorithms. So to compare the ROC curves, I define a function here, which you're getting the I test, the Y scores, and the label of the name of the algorithm. So that I can generally plotting all of the algorithms plot in terms of the ROC curves. So after I define the function to compute the AUC and the ROC curves, I plot all the algorithms so we can compare it together. Okay, so as you can see here is that, so the ROC curve and AUC curve can provide additional insights into the performance of the model beyond the accuracy scores. So a higher AUC score can indicate a better separation between the positive and negative classes, which means the model is better than distinguish between the classes. So I'm drawing 3 different lines corresponding to 3 different classes, which is the dropout, enrolled, and graduate. For example, for this logistic regression, we can know that the UAC score of the dropout class is 0.9, which is really good. The further away from the central line right here is the better the algorithm has performed. So from these scores, it's appear that the gradient boosting classifier and the support vector classification and the random forest models are performing better than the other models. The artificial neural network and the logistic regression model have the moderate performance, but while the KNN and the Gaussian naive Bayes and also the decision tree models had relatively poor performance. So the last is that I have a accuracy comparison right here. So by looking at these scores of all the algorithms, we can say that the artificial neural network and gradient boosting classifier are the 2 very good models to using this dataset, and the decision tree and the Gaussian naive Bayes is all the one that's performed was on this dataset. So to summarize on this project, so based on the provided training and test set scores, the gradient boosting classification has a really high training set score, which is 86.66% of the training set score, and the training forest has a perfect training core score as well as the random forest. However, that the test set score of the random forest is around 73.84%, as well as the decision tree. So this suggests that the random forest and the decision tree model may be overfitting the training data and not generalizing well to new and unseen data. Beside that, the model with the highest test score is the artificial neural network with the score of 74.88%, followed by the Gaussian boosting classification with a score of 74%. So this indicates that this model may be better at generalizing to new data compared to the other models. But however, it is important to also consider many other factors, such as the computational complexity and the interpretability of the models, in addition to their performance on the testset. So those are what I found in this dataset. Thank you for watching.